For this video, I'm going to demonstrate how to build the CSWA Practice Assembly 1. And the first thing you should know is it's really important that you understand how to download a zip file and extract the parts. And I have a little different setup here than you'll have, but what I like to do is show in folder, and then really, it's a good idea to create a folder, say on your desktop or in documents or someplace, and then you right-click Extract All and go to that folder, or by browsing. I'm going to make mine here in Pictures, and I can actually create a new folder, but someplace that you can access and you know where that is. And CSWA. And then select that folder and select folder and extract. And it will put all the parts you need in that folder, which you can access from SolidWorks. So where I just downloaded, I can't access it with this version of SolidWorks. I have a different location, but I know where that is. So here we go to start the assembly. So there's a couple ways to do it. One way, though, is to go New, Assembly, say OK. And then when I'm under the Assembly tab, I can insert, here it's asked to begin assembly, insert components, and then I have to browse to the folder. And in this case, I can't access the folder that I just saved it, but I have them saved in another location, and that is right here. So here are the parts that were in that zip file, and I also have the drawing open as well, and that's a PDF file, which it's going to look like this. Practice Assembly 1. And what this is going to do, it's important to read the directions. Make sure you are in millimeters, 2 decimal places. The origin is important, and I'll talk about that. If it asks for feature recognition, mine didn't here. You say no, click no. And then what we're going to do is assemble this part, add this angle, which happens to be 35 degrees, angle A, and then we're going to need to measure the distance and the center of mass, and then that distance. And then we'll modify that assembly slightly from 35 to 10 degrees and find the center of mass and that same distance. So I may refer back to this drawing now and then, but here I go. So the first thing we want to insert is the base. And if you know of the part that, if it's labeled base, that makes sense. But the first part that we assemble or insert will be fixed. And I'll show you that stuff too. So here's base, and there it is, and I just click and it drops that in there. Okay, on my PDF file, it's telling me that I need one base and one slide and one toggle and 2 cams and 3 pins. So I'm going to just go back in here and browse to the same location, insert a cam, I double click Browse, insert a pin. Insert a slide. Double click, and then I click to add it. Location is, we just basically want it on our screen right now. Slide and toggle. And we don't have to insert multiple. I need 3 pins and two cams here. We don't have to insert multiples. We can simply copy them. And this is a pretty slick thing. I hold the control key, click, and drag, and let go of the control key. So I need 3 of these. Hold the control key down, click, drag, and let go of the control key. Control key down, click, drag. And those are all the components I need. And we can see they're just out there in space right now. If I right click, this one says float, which means it is fixed. All the other ones say fix because they are floating. I can't grab the base and move it, but I can grab any of the other parts and move them. And as you build assemblies, you may need to unfix things and refix things. But for now, we definitely want the base fixed and everything else floating. Okay, I can move things close, and with this assembly, it actually works out pretty well where you don't have to move things too much. But sometimes, for instance, if this was flipped around here, and let me flip it around and demonstrate that also. We can just grab and move these here. If we go to move, we have some other options like collision detection and whatnot, but they still move. And this is just under free drag. But also, if we want to rotate these parts, this is pretty important. Underneath move is rotate. So I can click and rotate a part. So if I'm going to be mating this cylinder to this cylinder here in a moment, but if I mate this in this configuration, I'm going to end up with the plunger or whatever that's called on the wrong end. So if I'm starting in this layout, I don't want to mate, and here we can do it really quick and then undo it, mate that to here, and now I can't rotate it back. It slides and it's in the wrong configuration. So what I need to do here, I will delete that mate. Here, this is where all our mates are going to be. We'll have a dozen or so. Right click and delete that mate. Yes, I want to delete that mate. Now this thing is floating again, and this would be a reason why I'd want to rotate it and get it kind of close. Doesn't have to be exact, but it kind of picks the closest way to mate those. All right, so now I'm going to just start assembling this. I have no mates currently. Mate. And SolidWorks is really good at, we could choose what we want, but usually if you just click on the 2 surfaces or edges or faces, it works pretty well. So there, I just mated that. And this little box pops up. We can just hit this check mark and keep adding mates. That one was a concentric mate. So I'm going to mate this cylinder. It's important you don't grab the edge. You want to look for the cylinder. I'll make sure you're getting this cylinder. And there's a couple cylinders, but any of the cylinders will work, but you don't want to get the edge. Okay. That doesn't look like it's right, but it is. These holes line up. If we rotate, they're concentric. Okay. So now I can do a face mate, and I'm not changing anything here, or I guess it's called a coincident mate. This plane and this plane, check mark. Notice this moves and this moves, and they're constrained to the mates that we have given them. Okay. All right, now I can continue this. If we quickly look at the drawing, just so again we see where we're going. I have those two cams that are hooked to here, and then there's the three blue pins. So I'll just do those pretty quickly. This is a pretty simple assembly. So here I can make this cylinder and this cylinder, check mark. In this case, I'm going to, well, I can use it, put it on that side. This face and this face, check mark. I'm going to move this one over because I want to make sure I get the right face when I select it. But here I'll do this cylinder and this cylinder, check mark. This cylinder and this cylinder. If you noticed, that was the first one I connected to the base, which was fixed. So all of these kind of got square right now. This face to this face, check mark. I haven't gotten out of the mate box over here. I'm just keep continuing to add these mates. This cylinder to this cylinder, check mark. Now this thing works without the pins, right? But for the center of mass, it's going to be the wrong answer if you don't have the pins. So we want to make sure we add the pins. This cylinder to this cylinder, check mark. This face to this face, check mark. This cylinder to this cylinder, check mark. And let me close mates here. I have these mates done. You can see that this one still needs a face mate. I haven't done this one yet. But at any point, we can, here are all the mates we have so far. We can just stop, move things if we need to, insert a new component, and then go back to the mate tab at any point. For this, I wouldn't have even had to back out of it. There, check mark. This cylinder to this cylinder, check mark. This face to this face, check mark. All right. Now we have this thing moves and it works, as you can see. Let me, here's a good moment just to show you this, and I'll come back to, under move, we can have collision detection and stop at collision. So notice if I open this up, doink, doink, it stops right there. If we don't have that move, nothing stops it. It goes through. That's not important for this one, but later on it could be important. All right, so what we have to do now is make a mate that has, it's showing from up here to this surface at 35 degrees. So I'll go back to the mate tab. And essentially, I had something selected. See, that's that face. It's important that you double check this and clear this just so we really force our mates to be what we want. All right. So I could choose a face, or I could actually choose a line. Anything that is, if this was built on I can go in here and look at the toggle. Let's see the planes. I could choose that front plane, and that would actually work. Not the right plane or the top plane, but the front plane would work to get that 35 degrees. But I'll just do here. Okay, so again, back to this. Got a little pause there, and I'm going to trying to make these 35 degrees. So my selection here, either here, choose that and that, and then I can turn on the 35. It might be flipped. Let's see. So sometimes you just have to play with it till you get the right angle that or position you're trying to match in the drawing. 35. And that looks close. It may not look exactly like this in the drawing, but I'm confident that I have a 35. Here are all my mates, my angle mate. I could right click and edit, and it is 35 degrees. Okay. Now they want the distance. First of all, they want the center of mass. Evaluate mass properties, and it shows the center of mass here. Oh, my center of mass is way off, and I know why. On the drawing, it shows that there is the origin is right here underneath this plunger thing. So I'm going to add an origin or a coordinate system. So under assembly, reference geometry, coordinate system. The first one is a point. I might have to draw the point, but usually for these files they have there's a midpoint. And then I need to orient X, Y, and Z in the right direction. And if we look at this again, Y is vertical, X is this way, and Z is coming that direction. So in my X is this, my Y is this, I have to click on Z is this, and the orientation is upside down, so we can click that, and that is correct. It matches what's on the drawing. Check mark. Coordinate system 1. Okay. All right, now I can go to evaluate mass properties. This didn't change, but I do have a new coordinate system that I need to choose. Negative 0.02, 19.82, and negative 42.8. Let's see if that matches any of the 42.8, right, A. And at the end of these, some of them, they have the answers A. Now the distance, we have to figure out the distance here, and it gives us some options for that. There is a measure tool, and I personally don't like it. I never know what I'm doing. But what I find is better and suits my needs is to quickly make drawing from assembly. And you have to save it first, save the assembly first. Whatever it's called. And then file make drawing from assembly. And here we can just drag in our views. And escape. And now I can go to drawing, annotate smart dimension. And it is asking the dimension from here to here. Need to change this to millimeters, 51.58, and that is one of our options. I personally like to make the quick drawing because we can do a lot with it real quick. Whoops, I didn't have smart dimension. Angular, come on, give me my angular. There it is, there's my 35. And it's just the way I'm used to reading measurements, so if you're comfortable with the measurement tool, you're fine with that as well. All right, so now I got answers to questions A and B, and then it tells me to change angle A to 10 degrees and do the same thing. So just like a feature, I can go into my angle, right click, edit feature, 10 degrees, mark. We don't need any more mates. Mass properties. My center of mass is there, and that turns out to be exactly B. And now I can actually go right to my other drawing. And there it changed. It modified 49.9, and there's 49.9. Oops, don't do that. Move this out of the way. Okay, so hopefully that is helpful for assembly 1.